Hello world, let's take a look at WriteUp by HackTheBox. This was the second or third box I did on HTB, and it's still one of my favorites. WriteUp is located at 10.10.10.138, so let's take a look. Alright, so you can see here that it's using DOS protection that will block you after you get too many 40x errors. That means that Dirbuster, GoBuster, anything like that isn't going to work. You can also see down here, page is handcrafted with V. That'll come up a little bit later. So for now, let's just see what we can find with nmap. So we're going to do nmap-sc-sv 10.10.10.138. And because this can take a minute to actually finish, I ran it ahead of time and put the results in cherry tree. Now you can see here we got a Debian machine, Apache, but the big story is we got robots.txt and a page called WriteUp. So robots.txt, if you don't know, is a file that is used to tell search engine crawlers what pages they're allowed to visit. So let's take a look at that. And alright, in this case it's telling us, or telling a crawler rather, stay off of WriteUp. So now let's take a look at what we have in WriteUp. Alright, so it looks like this is basically a page where he's posting tutorials for other Hack the Box boxes. Notice that down here now it says this page was not handcrafted with Vim. So let's see if we can find out what it was crafted with. If you view the page source, you can see here it was made using CMS Made Simple. Alternatively, there's a really great Firefox extension called Wappalizer that will tell you what's running on a page. So if I click up here, you can see we got PHP, Debian, Apache, and again, CMS Made Simple. So let's see if there's anything we can exploit with CMS. Lots of options here, very dependent on the version number. Now, from the page source, we don't actually have a version number, so why don't we go to CMS's site and see if we can find out what version number they're running from there. So over on the downloads page, we have this repository here. So let's take a look in there. And doc, that sounds like what we're looking for. And then maybe changelog.txt. And yeah, you can see right here that lists the version number and the changelog. So let's pop back over to the WriteUp machine, and we're going to go to doc/changelog.txt. And you can see right up here, we are working with version 2.2.9.1. So let's take another look at our search exploit results. And you can see here we have an exploit that will work on anything below version 2.2.10. So let's take a look at that. Alright, so looking through this, looks like it's hashing things from a dictionary and comparing them against a password. You can see right here that it's putting a salt before the password. I point that out now because it's gonna come up a little bit later. And then down here you can see from the payload that it's using an SQL injection. Over here we have a sleep command in there, which will maybe look familiar to those of you who have done Nodus on Over the Wire. This is used if you're trying to brute force something character by character, but the server isn't giving feedback on whether the character is found in the string you're brute forcing. So you set it to sleep if that character is found in the string. Then you'll know that if a given guess causes the machine to hang for a second or two, that character is correct. Alright, so why don't we move this over to the directory we're working in and see if we can give it a shot. Alright, so we have that copied over, and now let's run it. Make sure you include the /writeup part at the end of that URL, or else the script will generate a bunch of errors, and the DOS protection we talked about before will ban you from the server. If that happens, you'll have to reset the box from the HackTheBox website. And then the word list we're using to try to crack the password is going to be the RockU list. Very useful list of millions of passwords that were stored in plain text by RockU and eventually got leaked. And then this is just a way of telling the script, yes, I want you to try to crack the password. So we're going to run that. And you can see that all those beautify lines in the script are giving us some pretty neat Hollywood-esque visuals as it runs. Now, when this was on the free servers, I had a problem where it kept crashing partway through getting the passwords. This isn't the most elegant solution, but to get around that, I wrote a quick script that created a text file where each line had a RockU password and its MD5 hash, and then grepped the partial hash I had, and that actually got the job done because the hash is in text, so even if you only have the first 9 characters, only like 1 in 70 billion hashes will start with that same combination of characters. Haven't had that problem now that it's over on the premium, but I'm just going to show you that while we wait for this script to finish running. So we'll get a new terminal window open. And let's see, what did I save that as? Alright, crack md5 hash .py. So it's a pretty simple thing. Takes the Rocky word list, takes the salt that we got over here, and then uses the hashlib library to encrypt everything, and then puts the original line, or the original password on the same line with the colon in between them, and then just saves that as hashes.txt. You can see when I originally wrote this script, I had it put the salt both before and after the password because I didn't read the exploit close enough the first time. So let's comment out the line that has the salt after the password, because now we know that the salt comes first. And we'll save that. And now let's give this a shot. Alright, so I took a little break, and both scripts are now finished running. The script that I wrote doesn't have any fancy visuals slowing it down, so it would have finished quite a bit faster. So let's take a look at the results. We have ls, so you can see there's now a hashes.txt file, and we'll just take a quick peek inside that. And you can see it's got a bunch of hashes separated from common passwords by a colon. There's a billion of them. So let's get out of there. And now we're going to cat hashes.txt and then grep that for, we'll just take the first 9 characters of that password hash. I think that's about what I had the first time I had to do this. And you can see that gives us raykj9, same thing as the password that the script found. Now that we have the password, let's see if we can get a shell. So there's our shell, and there's our user flag. There's a popular program called Pspy that a HackTheBox user, I think his name is Dominic Brucker, made, and that lets you see what's running on the box, and it comes in handy here. So let's get that on the box and see what we can find. So this just allows us to basically download programs from our computer to the box that we have the shell on. Pspy 32. And there we go, it's downloading. And you can see it downloaded. Now that just makes it executable. So you can see it's green now, signifying that it is executable. So we'll run /pspy32. And now you can see what's running on the box. And the paths that it's running from. So this is a little hard to recreate naturally now that the box is no longer free, but when a user logs in, there's a program that runs called run parts. So if I log in from a new window, you're going to see run parts pop up in the Pspy window. And let's see, where did it go? Yeah, there we go, right there. Now, as you can see, run parts, unlike down here by example, does not have an absolute file path. It uses a relative path, and that is what we can exploit here. So the way this works is when you run a command without an absolute path, the first place it will check is user local bin, and then user bin, and then bin, and so on. So if we were to put a file named run parts in user local bin, whenever a user logged into the box, it would automatically run the run parts that we put in user local bin rather than the one that it's currently running. So let's check out user local bin and ls-al. So let's hit ls-al to see what permissions we have here. Permission denied. Alright, so let's go up a level. And we can see that, alright, it's owned by root, and we have the group staff. Our user is in that group, so we have write permission, and when we execute something there, it will set the user ID to root. So let's go back into bin, and we'll do bin run parts. Alright, we'll do v run parts. So what we're doing here is we're telling the machine that when this runs, send a shell to 10.10.14.34 port 1234, which is our machine, and then we just have to set up a listener on 1234 in order to catch the shell, which we will do in a minute. So we're gonna right quit. We're gonna come over here and set up a netcat listener on port 1234. And then we are going to open yet another window, and we're gonna get back into the write-up box, RayKJ9. Alright, so that didn't work because I forgot to make my run parts executable. So we're going to do that real quick. And then we're going to exit here and log back in. And as you can see, we have our root shell now. And there's our root flag. Thanks for watching, guys.